In this problem, we want to determine if the SiO2 molecule is polar or nonpolar. And to do that, we'll need the Lewis structure. So we'll start out SiO2, and a real quick reminder that for silicon, we'll have 4 valence electrons, and for oxygen, we'll have 6 valence electrons, and remember we have 2 of those, so that'll give us 6 times 2 is 12, 12 plus 4 is 16 valence electrons. So silicon to oxygen minus our 4 will now give us 12 valence electrons that we need to spread around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we can see that our silicon and our oxygen aren't happy with their octets. So we'll move that lone pair here. We'll move that lone pair in because remember each oxygen only wants to have 2 lone pairs. And so we'll have Si double bond O with our lone pairs on the oxygens. So that gives us our Lewis structure, and that's going to be useful for us to figure out the symmetry for our molecule. To figure out the bond polarity, we'll go to our table and we'll look it up, and we'll see that silicon has a value of 1.8, and that oxygen has a value of 3.5. So we'll just figure out the difference. It'll be 3.5 minus 1.8. So 1.7 is our difference in bond polarity. And so this would be a polar covalent bond. Now, the last question that we have to ask is from our Lewis structure. Are there any lone pairs on this silicon atom? And we can see that there are no lone pairs. Is this molecule symmetrical? It is. We've got symmetry this way, which would divide the molecule the same left and right. And we also have symmetry through the center that would divide the molecule top to bottom. So we could rotate it around and it would be the same. Because this is symmetrical, even though it has polar covalent bonds, SiO2 is non-polar. And it's because of the symmetry.